Let's go back to share screen 2. All right. Okay, so yesterday we finished up our slides on SQL and the the data manipulation language part of SQL. So basically, how to query for data, how to view using the select data, and how to manipulate data through updates and deletes and inserts. And now it's called advanced SQL. I'm not really a big fan of the chapter title on it, calling it advanced, because it's not so much that it's advanced. It's more just that it's a different side of SQL, and that it's the type that the data definition language side of things, where what we're going to do now is we're going to talk about how to create the structures themselves. Okay, how to create and manipulate the structures themselves. So kind of an outline of what we'll talk about. All right, so in programming, we have different data types, right? We have Boolean data types, true, false. We have character and string. Now, you'll notice here on this slide that there's no string data type. Right? There's nothing called a string, and that's because in SQL they don't refer to them as string. What we will refer to them as is varchar. Okay, now varchar, variable character string. Basically, a variable character is the abbreviation here, and it is the string type. So it is the it is the type of data type where you're going to put text into that. There's also text can also go into what's called a large object. You'll hear in some database management systems, they'll talk about the blob, and the blob is basically it's a large object for holding text. It stores text in a slightly different way so that it can compress it better. Varchar is easy for searching strings and doing other types of manipulation. Blobs are not so much. Blobs are used for being able to store large amounts of text that does not change frequently. Okay. Okay. Then there's some other types in the numeric types. Notice there's no specific double type. This would be the double precision. Okay, it's just don't expect that all your data types that you used in Java or C or Python or whatever language you're most comfortable with, don't expect that it's all going to be the exact same names as data types, but a lot of them will be the same types. So you have integer, small int, big int, and basically this is just integer is an integer type. Small int is an integer type, but it doesn't take up as much space. It doesn't use as many bits to represent the number, and so therefore we don't take up as much space on the server, but we also don't get to make the numbers as large. So a small int might be useful for something that where we don't need large numbers for this thing. It might be something like if we stored someone's age, for example, in years. We wouldn't want to store, we wouldn't maybe want to have something as big as an integer, right, for their age in years, because that'd be a lot of wasted bits. No one gets to be above, 120 years old, right? In fact, I think average age for most people, our average age is what, like 70 is what we get to live to at this point. I don't know. But anyway, you wouldn't want to use a bunch of wasted bits, right? So you might use something like a small int. A big int, like a long, is something where it can store a much larger number, but it takes up more space because it uses more bits to do it. You might use a big int if we wanted to represent something like your student number using an integer format. I have no clue, by the way. I don't know what format, what data type your student number is in the server. I would imagine it's a string, just because Larger numbers can be messy, but I don't know that for a fact. So anyway, but it could be either. It could be a string. It could be an integer. It could be a double, and yeah, it could be lots of. It could be a couple of different things. All right. So this is basically the data types that we'll be working with. Now we're going to consider 5 types of what's called integrity constraints. Now this is going to be constraints that we are going to put, requirements that we could put. We don't have to on every piece of data, but it's going to be a requirement that we'll put on a column, right, to make sure that certain things hold true in our database. Okay, so some different types would be required data. Would be if this data, we have to have a value in this column for every row. Domain constraints could be if we wanted to make it a specific set of values. Entity integrity is related to the primary key. Referential integrity simply means that if there's a relationship between 2 tables, that the child table, whatever it's considered the child table, in the relationship will, if it has a foreign key column, it will have, if it has a value, that value will exist in the parent table. Okay, so let's talk about some examples of these. Okay, so required data. We might say that a particular column cannot be null. Right, simply saying you cannot put a null value into this column. If you put a new row into this table, if you update this value for a specific row in this table, the value you cannot make it a null value. Okay. Some examples of things we might want to make not null. Username, right? Someone's username in their system. What else? Something. Password, I guess, right? If we have a password column in a table, we would want to make sure it's not null. What do you guys think? What are some other examples of things that accounts that you've created? You know, if you've ever created an account on Hepsiburada or Gitigidior or this university system, let's have a little wake up time. What's an example of something where you were not allowed to put a null value in? All right, student ID, yeah. Others? Email address? Is that mail address or email address? Yeah. Yeah, an email address. We have to have some way to contact you. I know one that I bring up with you guys quite frequently that comes at the end of the semester. Comes when you are right before, my understanding is before that you get your grades, before you're able to see your grades in the OBS system, there's something you have to do. Do you know what that is? Ah, yeah. Yeah. Oh, you gotta have a credit card information on Netflix. I'm not so sure about YouTube though. I don't think I put up my credit card on YouTube, but I don't pay for anything on YouTube. I'm not a part of YouTube Red or whatever it's called. Yeah. But think about, okay, I want you guys to think about one, because I do like talking about this one. It's one of those pet peeves, maybe. So when you come to the end of this semester, when you come to the end of any semester, before you can see your grades, you have to fill out a survey. right? You have to fill out a survey about the course, right? Where you rate, aspects of the course, the aspects of the teacher, right? And there's a particular field, yeah, and there's a particular part that you cannot leave blank, right? Is that correct? That there's a particular part that is, yeah, the comments, right? Comments, like, additional comments you want to make, you're not allowed to leave that blank, right? You know how I know? I don't know that because I've never used it. I've never used that system, but you know how I know that those comments cannot be blank? I have no, I've not seen the inside of the system, but I've seen comments like, and I'm going to type a few of them down here in the chat. I've seen comments like this. Right. These are some of the comments that I've seen. Okay, in the courses that I've taught. Right. So the intention of requiring comments was that you would have to say something about the course. But these comments aren't very helpful, are they? In fact, you know what? I'm going to do this. I'm going to comment on my own post here, Right. And the reason why these are not helpful is because they don't tell me anything, right? I can even tell you that I've seen comments like, well, I won't write these, but I've seen comments like, oh, this is the best class. Oh, this is the best teacher. Thank you so much for the compliment, right? But again, that doesn't even really help me, right? You could. A string length requirement could be good. Yeah. Yeah. So Toronto, that's a good idea. But what I'm encouraging you to do is I'm encouraging you not to just do the minimum just to get to your grades real quick, but really help me become a better teacher. Okay. So comments like, this is something I liked about the course. I like that the professor uses a quote of the day every day. That's interesting and helps me, get ready for the class. Okay. Or you could say something like, I don't really like that the professor does quote of the day because I think it wastes our time and it doesn't get us to the topic that we need to discuss as quickly. So either one of those would be a good comment for me because it helps me know what kinds of things are good for my students and helpful for them to learn and what kinds of things are not so good and not helpful for them to learn. Okay, so I'm asking you guys to go ahead and use real comments there. But what all this is back to a tech thing is the reason I know that that field cannot be null is because there's always something there. I've never had a single survey. I've never had a single, I guess, what'd you say the word was? Anket? Is that the Turkish word? Anket? Or I've never seen a single response to one of those where the student didn't type in some string of characters. And oftentimes it's these ones that I've shown here above, the just a single character or a couple of random characters. And that tells me that the system has put a not null integrity, a not null required data constraint on that field. So there you go. And it's not a whole lot of programming that's necessary. As you can see here, you just simply say that when you create the column, you say not null. Can't be null. Okay. Now you could put what you're talking about is this right here. I like it. Yeah, Master Yoda is great. All right. What you're talking about, Tarana, is here. Is we could put a constraint that would say must be at least so many characters, right? Must be at least 10 characters, must be at least 15 characters, something like that, right? But here the example they've given us is they said, okay, we're going to check that the value is in one of these two. Anything outside of that is not allowed. Now I'm going to pause here for a second for two things. At least two things I want to make a note of. One, MySQL does not support check constraints. So what this in the current format. So what this set of slides as far as these check constraints are concerned, and we won't spend a lot of time on them, we'll just kind of zoom through them a little bit. Because they're not supported by MySQL, okay, you cannot do these check constraints, but other database management systems do allow for them. Okay, they're a useful tool, but MySQL, because it's a kind of a open source freeware type thing, there's a lot of stuff that it does not support. All right, I wanted to say that. What was the other thing? MySQL doesn't support it. Oh, and the other thing I wanted to say is when we do have a constraint like this, like a not null constraint or a must be in a certain value constraint, the domain constraint, is anytime we do something that violates this. So if I try to insert a row with a null in a column that's not null, not able to be null, or if I try to put in update a row where changing the sex to something else that's not one of these two, it does not put in some default value. It does not. It just rejects the entire transaction. Okay, so if I try to insert a row and I try to put, and if I were to try to put a null value into the position field, the entire row would get rejected. It would not get inserted at all. If I were to try to update a table, update a row, changing sex to something else, changing some other columns as well, none of them would get changed. It just would not happen. The entire transaction would get rejected. Okay, so we don't do some things and just ignore. Think of it like it's like an exception, but it's just an exception you never really see. So an exception just kind of gets rid of everything, right? In the same way, if we try to do something that's not allowed, then it will just reject the whole thing and it won't do any of it. Okay. All right. Some other so we could also create domain, right? If we wanted to have a domain that might exist for multiple types of multiple columns or in multiple tables, we could create a domain and then just use that domain instead of just putting it in the table itself. Okay. Again, so let's go ahead and I'm going to skip through some of these. Okay, entity integrity basically means that a primary key of a table must be unique. So every row must have a unique primary key value. So if the primary key is a single column like this, then that just means that every row in the table has a unique value in the staff number column. Okay. If the primary key consists of two columns, then what that means is that the combination of these two must be unique. So you might have the same client number multiple times, you might have the same property number multiple times, but what you won't have is the same client number and property number combination multiple times. Okay. Now, we can have a primary key that is automatically unique. Then we can also have other columns that we say we want them to be unique as well, but they're not our primary key. An example might be we might have a primary key on the student table that is your student ID, and we might have a unique constraint on your email address. All right, so your email is unique. You don't get to share your email address with anyone else, any other student in the system, but your primary key is your student number. That would be an option. That would be a type of thing that we might do. Okay. All right. Also, one other thing. Every column in a primary key must be not null. So staff number, we cannot have a null value. Remember, null, because it means unknown, we don't know if it matches anything else, right? And so if we had a null value in staff number, for example, we don't know if that matches, that unknown value matches some other known value. Right? So we cannot have any columns in a primary key be null. All right. Now, referential integrity, this one's an important one. All right. Basically, what this is saying is that if a column references a column, if one column in one table references a column in another table. So if a foreign key in one table, it references a primary key or a candidate key in another table, okay, then that means that if there's a value in the foreign key, it must exist in the other table. Think of it like this. If I had a table for this course that said, okay, that listed all the students that are in this course. And let's say it listed them by student number. So it's like, it's all, let's say it's a table that has this course and all the students are in this course and what their grades are. I might have a column that's the foreign key student ID. And basically, instead of getting all of your information in the course table, instead of having your name and your email and your this and your that, I might just have just one piece of information, one row, one column, student number. And then that student number, to get all that other information, your name, your email address and all that, to get all that, right, I go to the student table to find out that information. Now, if there's a value in my course table for a student, but that student does not exist in the student table, that's a problem, right? That means that there's a student in the course that's not in the university. That's not okay, right? That's a problem. All right. So we must make sure that if we have a student in the course, they are also in the university. They're in the student table. Okay? And that's how we establish that. We establish that using a references keyword. So we're saying the foreign key on a specific column in our table references another table. So the way we might say this for the student, foreign key student ID references student. And it just knows this references this table's primary key. Okay. And what happens now is if we try to change a value in the course table, we try to add a new student, it's going to check, does that student exist in the student table? And if not, it will reject the insert. It will not allow the insert. If we try to change a student number to something that doesn't exist in the student table, it will reject that. It won't allow that. Okay. Which brings us to what can we do? Let's say we wanted to delete a student from the student table, but they exist in the course table for this course. Well, there's 4 possible ways that we can handle that. When we try to update or delete a primary key or a candidate key value in a parent table, but there's a child table that has rows that are dependent on that have that value, right? Then we can say on update, do certain things, and on delete, do certain things. And the 4 possibilities are cascade, set default, set null, or no action. Okay, so let's talk about a little bit about what each of those is. So in each of these situations, let's say we are changing a value in a parent table. We are, and there's a child table that depends on it. Okay. All right. Cascade. Cascade basically says what I did in the parent table, I want you to automatically do that in the child table. So if I delete a student from the student table, it will automatically delete that student from any courses that they are in. That seems like it would make sense to do that, right? Okay, so Cascade simply says whatever you do to the parent, do that into the children as well. If I update the student number for a student, update their student number in the course tables as well. This is very useful, right? Because what this means is that let's say you had a student table, and those students existed in courses, they existed in clubs, they existed in other things as well. Maybe they had some library. Maybe there was a library for books that the student had checked out. Right? They exist in all these other things. Right? If we can say delete from student, and that takes care of all those other tables. We don't have to go write separate other queries for all those other tables. We don't have to keep track of, all those other tables and delete from them first. We just have to write one statement: delete from student where student ID equals whatever. All right. So that would be how the cascade would work. It would go into and do all down for all the children table, whatever it is we did for the parent. Okay. Set null would be if we deleted a row from a parent, right, and we set the values in the foreign key table to be null. Okay. So this would be if we didn't want to lose the child row for whatever reason. Maybe there was something specific we wanted in that, but we wanted to lose the parent row. We wanted to delete or update the parent row, and we want to keep the child table information. An example. An example might be if you had files that belong to certain people, like references to files that belong to certain people in your company or organization. You delete or get rid of or update the user table, but you don't want to lose the files that belong to them, right? So you might set them to null because now they don't belong to anyone. Okay. Or in our example of this dream home stuff, right? Someone's managing a property. We delete that staff person from the staff table, but we don't lose the properties. We want to just set it to null. No one's managing it for now. Okay. We can also have a set default. It's kind of like set null, but a default value would be if maybe in the example like I just gave, we might have whoever, if we delete the staff person who's managing a property, we might set the default to be the owner of the company or some particular manager whose job it is to then reassign it. Okay. All right. And then no action would be that if there are child rows, we reject the transaction. If there are child rows, if we don't have this on delete or on update, do whatever, this is the default. So if we say no action, then if we try to delete from the parent table and there are child records, there are child rows that exist, we just reject the entire transaction. We don't delete from the parent at all. We don't update the parent at all. Okay. All right. Okay. Let's, again, I don't want to get too much into the check constraints. I do want to talk through about how we create and drop structures in the database. So basically, to create a new table or to create a new view or to create anything, we use the create keyword. So create table and then some information about what the table looks like, or create view and then the SQL query that represents the view. Okay. We can also alter table or alter domain, but we can alter table to add a column, to remove a column, to change the constraints of a column. Okay. So create is kind of like insert in that it adds something to our database, but the difference is that insert adds data to a table, create adds a structure to our database. Drop, on the other hand, kind of like delete, but delete just removes data. Drop actually gets rid of whatever the structure is. Drop is also one of those things, it's not, you can't come back from this, okay? If you drop a table, it not only gets rid of the table, it also gets rid of the data inside. So if you drop a table and you had data there that you needed and you lost it, it's gone. Okay, so be real careful. Make sure you delete from table if you're trying to get rid of individual rows or data. Drop table if you're trying to get rid of the entire structure. Okay. What else did I want to say there? Oh, drop things doesn't come with a where clause, right? You don't drop table where something, because that would, that's not conditional. You're just dropping you're getting rid of the table structure itself. All right. So let's talk about the one that's most often. This is the this might be a little bit overwhelming to look at initially. We'll walk through. Basically, the main things you'll need to know is you're going to create a table with a specific name. You're going to give it a list of columns with a possible not null or unique constraint, possible default option. You can give it at the end of all the column list. You can tell the table creation what the primary key is, what possible unique constraints are. Now note this is different from this unique. If we put a unique keyword on a column, we're saying that column is unique. If we put a unique down here, we're saying we can put a list of columns as unique. Okay. We can define what a foreign key is. A foreign key references what parent table. Notice this is all optional, right? You don't have to have foreign key columns in a table. Right. Okay. And then what to do on update and what to do on delete. Those are the main things I want you to come away with. Now, I think we best learn through examples. So let's take a look at some examples. Let's look at an example of creating a table. Right. So here we're creating a table called property for rent. Now, the way they've done this is they've created these constraints here, these domains and other constraints and stuff, and the check constraints. Again, unfortunately, MySQL does not support this, and so you'll have to kind of refer back to this. Let's just take a look at like this P number is varchar 5. Let's just use that as an example. So here we put it here. So basically what this is saying is that the property number is a varchar 5. What that means is that it's a string and it can be up to 5 characters. Okay. So our property number is some type of string up to 5 characters. Then rooms, I think, was an integer. Is that right? Small int between 1 and 15. Okay, so basically you have column, type, and can it be null? Column, type, can it be null, and what's the default value? There's a default, which means that if we don't give a value to rooms, it will automatically put in 4 for us. Okay, rent, type, it's not null, and what default is? Owner number, staff number. In some DBMSs, you can have this extra constraint that makes sure that their number doesn't exist so many times in the property for rent table. Branch number. And then after we've defined all of our columns, we now have, okay, what's the primary key? Now, automatically, just by saying that the property number is the primary key, that takes care of this has to be unique. All right. We cannot have the same property number more than once. It will also be identified for any children tables of this, as when we do a foreign key back to this table, that will be the column it will go to look for. Okay. There's also something called an index we'll talk about later that gets put on this column as well for easy searching and for quick reference. Okay. And then we have finally a foreign key staff number that references the staff table. So what we're saying is the staff number here, right? If we want to find out who the name of the person managing a specific property is, we need to go over to the staff table to find that out. We don't want to store that in the property for rent table. When we talk about normalization in a couple weeks, you'll understand why that is. But we don't want to store things like the staff person's name and their salary and all that in the property for rent table. We only want to store one piece of information. What is their ID? What is their staff number? And we can go to the staff table to get all of that information, all that other information. Okay. On delete set null, what that means is that if a row gets deleted from the staff table, and if that staff number exists in the property for rent table, we are going to set that column to null. Okay. Notice that staff number does not have a not null constraint. Right? Staff number does not have a not null constraint. It's maybe hard to see, but because they don't have a not null constraint, it can be null. It can be a property that's not managed by somebody. Okay. Then on update cascade, and what that means is that if the staff number changes in the staff table, if we update the staff number in the staff table, change it in the property for rent table to the same value. So if the staff person, if their number changes, we change it here. So what does that do? That maintains that whoever was managing the property before, if their staff number changes, they're still the person that's managing the property, right? And that makes sense. Okay. So this is how we create a table. Column, type, possible not null constraint, possible default value, possible unique constraint. All right, primary key, foreign key. It's good practice to always have a primary key. Not a requirement. You can create a table without a primary key. It's just not advised. We can also alter tables. Let's say we decide that we want to add a new column or get rid of a column. Okay. So we can alter table staff to alter the position to drop the default. So let's say there's a default value for position. We want to get rid of that constraint. We want to alter table staff to have the sex have a default of female, right? By the way, that makes sense because there are more women than men in the world. And so they outnumber us. And so it makes sense that the default would be what shows up the most, right? Okay. So that's how we can alter table. We could alter table to drop based on some check constraints. Again, not something that MySQL supports, sadly. We can also drop tables. Now this one again, be very careful with this. It's very easy to type this, very easy to run this, and once that table's gone, it's gone. All right. It removes the table and all the rows. It's like, whoop, it's gone. Think of it like back in the old days, back before everybody had laptops, when we had desktop computers. If the power went out, your computer was gone, right? There was no, it doesn't matter what you were working on, it's gone. All right. In the same way, drop table, it gets rid of it completely. Okay. Views are very powerful. Views act like tables, but they don't store any data themselves. They dynamically give us a result of a set of tables based on a set of underlying tables in the database. Okay, it's kind of like a temporary table, and we can use it like a table. All right. Basically, we can create a view with a specific name with a select. Okay. We can assign a new column, a new name to each column in the view. Again, this does not change the column name in the table itself. It only uses the new column name. It only uses the new column name when we use the view itself. Okay. So basically what we could do is we could say, okay, I want to create a view called manager 3 staff that has all the managers, that has all the staff who work at a certain branch. We would call this the horizontal view because it takes all of the rows horizontally, all the columns, takes all the columns, that's what the star means, right? Takes all the columns, but only a subset of the rows. Mm-hmm. So if we were to just run this query on its own, we would get this set of records, right? So when we look at so if we were to say select star from manager 3 staff, we would just get this as well. Okay. A vertical view would be where we only want certain columns. So let's take a look at this, for example. You have the branch number, which really we don't need, right? Because we already know what the branch number is. Salary, what if we don't want, whoever needs to view this, what if they don't need to know what the salary is? Date of birth, they might not need to know that. We can limit what columns, right, by a view. We can say we want only these columns. All right. Staff number, first name, last name, position, sex, from staff, where branch number is a certain branch. Okay. One example we looked at yesterday, this will be the last example before the break, and I'm not moving as fast as I had hoped I would today, but one more example before the break. Yesterday we talked about this whole the count, creating that table and inserting into that table based on the number of properties that a staff person was managing, right? And you remember that select query looked something like this, right? Ignore the view part just for a second. It looked like this, right? Now you may remember that there was also, when we inserted the records into that temporary table, we had this union for all the people who did not have any properties at all, right? All right. We don't have that union here, and that's okay. But now, instead of creating a table to insert into that, we can just do this as a view, where dynamically, every time we run this view, we will get this result. We will get the result of however many, the branch number, the staff number, and whatever properties, the number of properties that they're managing. Now, the reason why we may want to do this as a view is because what if this information changes frequently? What if this information changes frequently? Then every time that someone takes on a new property or stops managing a property or whatever may happen, if we stored it in a table, we would have to always update the table. We have to run an update on the query, an update query on the table every time something changed, right? And that could get it could be inefficient for our system. It could result in bad data that's not always correct. Whereas if we store this as a view, then this dynamically always looks at the existing data in the staff and the property for rent table. So it's always correct based on what's in those two tables. We don't have to have any scripts that keep things going, that keep things updated. All right. Okay. I said one example. I do want to go ahead and say one more thing. Dropping views, just like tables, instead of drop table, we simply say drop view and whatever. And dropping the view gets rid of the view as well. Okay, just like it does with the table. All right, so it's 9:24. What we'll do is we will take a break, come back at 9:35, and what we'll do is I will go ahead and keep to what I said yesterday, that we will do examples, because we did do a lot of new SQL yesterday and we did do some new stuff today as well. So I want to go ahead and do some examples and not lose out on that. So what we'll do is we'll push off the rest of the DDL SQL to next week. So we'll talk more about, we'll pick up with view resolution. We'll pick up with view resolution next week. But today in the second hour at 9:35, we will start with examples from yesterday's discussion and today's. All right. See you in 10 minutes.